Okay, fine then. We will have our regular lecture now. So the next thing which I am going to do now is, in order statistics, we have seen how to find PDF of a single order statistics. That is, we obtained the expression for G of YR. We have also seen the expression for joint PDF, that is G of two order statistics, that is G of YR comma YS. And now I'm going to derive the expression for joint PDF of all n order statistics. Okay, that is, I'm obtaining the expression for G of Y1, Y2 up to Yn. Okay, so for that, let x1 to xn be a random sample of size n taken from continuous population with PDF small fx and distribution function capital Fx. To find joint PDF of n order statistics, consider G of y. We want to obtain the expression for G of y1, y2 up to yn. Now, if you remember the same steps, I'm going to repeat over here. Which steps? The steps we did for this joint PDF of rth and sth order statistics. What we did, G of yr comma ys is equal to G dash of yr comma ys, right? So what is G of yr comma ys? In terms of limit, it is limit h tends to 0, k tends to 0, capital G of yr plus h ys plus k minus G of yr ys upon hk. So basically we use the definition of derivative in terms of limits. Same steps I'm going to follow now, but instead of two variables, now we have n variables, right? So I'm taking limit over delta y1 tends to 0, delta y2 tends to 0, up to delta yn tends to 0. Why I'm using the delta notation? Because see, if you remember, in earlier cases, I used h tends to 0, k tends to 0. But now I have n variables at a time, right? And I cannot write y1 tends to 0, y2 tends to 0. So I'm using, because it is basically a very small interval of length delta yi. Okay, so in terms of limit, what I can write is limit all these delta yi tends to 0, g of y1 plus delta y1, y2 plus delta y2, so on yn plus delta yn minus g of y1, y2 up to yn divided by delta y1, delta y2 up to delta yn, right? So just like limit h tends to 0, f of x plus h minus f of x divided by h, right? Now this step also we did earlier. What is this step? So what can I write for this? Limit delta yi tends to 0, each yi, for each I, right? If you remember from earlier step, this is nothing but p of y1 lies between the first interval, y2 lies between the second interval, so on, yn lies between the last interval, divided by delta y1, delta y2, delta yn. How this come? If you remember from the earlier, this I did earlier, right? This is nothing but yr lies between yr to yr plus h, and ys lies between ys to ys plus k. Same steps we are following, but instead of now two variables, we have n variables, right? So on the number line, how can I show it real line? What do I want? I want y1 to lie between y1 to y1 plus 1, y1 plus delta y1. y2 to lie in between y2 to y2 plus delta 2. So on, yi to lie between yi to yi plus delta yi. And yn to lie in between yn to yn plus delta yn, right? Now corresponding to y1, there will be 1 of xi. Not necessary it will be y1 or x1, but any one of the xi, because what is y1? It is smallest of all. What is y2? Second smallest. So corresponding to each yi, there will be 1 of the xi, right? So what do I want in terms of xi? 1 of xi should lie between the first interval. 1 of the xi should lie between the second interval. 1 of the xi should lie between the nth interval. So, right? So if you imagine, this is again a multinomial situation. What is the multinomial situation? There are n trials. Now, in this case, what are the n trials? The n trials are, I'm taking the first observation, in which n possible boxes it will lie. It will lie within any one of the n boxes. Let's call these intervals as boxes. Right? I will take the second observation. In one of the interval, it will lie. I will take the third observation. Again, it will lie in one of the intervals or boxes. Likewise, I will take the nth observation. It will lie within one of the boxes or interval. Right? So, if you remember, how shall I? Okay. Then how to find the probabilities? Consider the first interval. What is the first interval? One of the xi will lie between y1 to y1 plus delta y1. How many xi's we want to be there in this interval? Only one, right? Then what is the probability that the xi will lie within this interval? It is nothing but probability of xi. Okay, let me show it with the help of Jamboard. You need not have to join the Jamboard, just it is a procedure. So I send you a request to join, but you are not expected to join it because you are not going to do anything on the board. Yeah. Okay. So what are we doing now? I want one of the xi should lie between y1 to y1 plus delta y1. Sorry. Right? One of the observation should lie between y1 to y1 plus delta y1. Now, what will be its probability? Its probability. Similarly, there will be n intervals in which we want one observations to be there. So now I am interested in finding the probability of one of the xi is lying between y1 to y1 plus delta y1, right? So what will be this probability? This probability, see, anyhow, what I know the distribution of xi's. And hence I know the cumulative distribution of xi's also. So once you know that whatever information about yi's is there, you have to convert it into information about xi's because that is the only thing which we know. So what will be this probability? Xi lies between y1 to y1 plus delta y1. So I am going to write it probability of xi less than y1 plus delta y1, मतलब यहाँ तक की probability from minus infinity. Right? So I will write it as probability of xi less y1 plus delta y1 minus probability of xi less than y1. Okay, try to understand it. I want probability of this. This I am writing it as xi less than y1 plus delta y1, मतलब यहाँ तक के एरिया, minus xi less than y1, मतलब यहाँ तक के एरिया. Right? So if I take difference between these two, what I will get? I will get this area, right? Which is required. And now what is this? This I can write it as capital F of y1 plus delta y1 minus what I can write for this is capital F of y1. Right? The same thing I was telling you. So first interval is xi is lying between y1 to y1 plus delta y1. How many observations are there? One observation. What is the probability? Just now I have shown it to you. F of y1 plus delta y1 minus f of y1. Right? Same case, you consider the second interval, xi lying between y2 to y2 plus delta y2. How many observations? One observation. What will be the probability? F of y2 plus delta y2 minus f of y2. Right? In general, for all of the remaining also, I will write the probability in the similar fashion. Right? So what will be g of y1 to yn? Since it is a multinomial situation, I will write limit delta yi tends to 0. How to write the multinomial PMF? You will see in Namrata madam's paper now. How many total number of observations are there? N factorial. First interval में कितने चाहिए हमें? 1. So 1 factorial into 1 factorial. Each interval have one observation. So 1 factorial into 1 factorial n times. What is the first probability? Just now we obtained f of y1 plus delta y1 minus f of y1 raised to how many such observations are there? Only one. So not mentioned. Similarly, each probability you will write divided by delta y1, delta y2 up to delta yn. Right? And now I will take the limit inside. This is nothing but n factorial into limit delta y1 tends to 0, f of y1 plus delta y1 minus f of y1 upon delta y1. Second, limit delta y2 tends to 0, f of y2 plus delta y2 minus f of y2 upon delta y2. So on. Last will be limit delta yn tends to 0, f of yn plus delta yn minus f of yn divided by delta yn. Right? Now what is this first? F of x plus h minus f of x upon h, limit h tends to 0. It is nothing but small fx. Same case yahan pe. So for the first limit quantity, I will write small f of y1. Second, small f of y2. So on. Last will be small f of yn. And this n factorial as it is. Right? So in general, how can I write PDF of joint PDF of all n order statistics? It is g of y1, y2 up to yn is equal to n factorial into f of y1, f of y2, so on up to f of yn, right? Now, if xi's are lying in between minus infinity to infinity, your yi's will also lie between minus infinity to infinity, but y1 will be less than y2 less than so on yn, because they are now order statistics, right? So this is the expression for joint PDF of all n order statistics. Is there any doubt in this? Any doubt in this? Any doubt is there? We'll stop here and we'll continue in the next lecture.